Welcome back. We are in episode 8 of the Crownsmen podcast. We're doing a very special episode today, and I say special because I understand almost nothing about this next topic. I'm your host, Jared Downey. I'm the president of Crownsmen Partners, and my lovely co-host is Gaudi Molina. She is the director of management and training for Crownsmen Partners. So you keep the ship going in the right direction.
That's right.
And me during the podcast quite often.
That's
yes.
right.
How's the show been so far?
The show has been fantastic. There's been so many people and a lot of people who've walked by, and our team has been incredibly good at getting people, into the booth, talking about their company, wanting to know more, and handing out Marties.
Yeah, the Marties are a huge hit.
Everybody, yeah. And the funny part is they all kind of walk by pretending they don't want one.
Yeah.
We know they do.
Yeah. For anybody who isn't just maybe you've happened to see or listen or watch the podcast for the first time, we are live at CIM in Vancouver. It is one of the biggest mining shows in North America. There is, I forget how many exhibitors are.
There's about 400 exhibitors,
yeah.
Give or take.
Yeah.
They're all, it's nice because they're all in one place. So you can walk around, get to know everybody. This is the second day. Yesterday was the first, open only to exhibitors and delegates. So it was kind of nice to get to network with each other, and now it's open to the public. So it's a lot more people, but again, fantastic.
We've got hundreds of cards,
yes.
and we're not even going out to the booth that much. Just
No.
people just coming in. It's been absolutely crazy. They do a lot of forms to the within. So there's the trade show element where the companies are, but then they do these forums where people are talking and that.
Yeah.
So
they do a lot of like workshops,
yep.
that kind of thing. So there's a lot of speakers and delegates that come down for these workshops. We were actually talking about one of the workshops in a previous episode of the podcast. Yeah.
And so the topic we're talking is actually there was a workshop on it, and one of our guests, Brent Hilscher, is coming in from Sacra Davy Engineering. And he did a workshop. I'll get him to give the details about it. But it's about a newer technology that really is going to be a part of the mining industry in the next few years. Sensor-based ore processing.
Yeah.
And it's I'm not going to talk about it very long at all because really Brent, he knows about it, and he will explain it to us because if I sit here and try or we try to navigate through it, we'll probably make it more of a mess of it than. So I'm going to ask Brent to come and actually join us live from the podcast. I got him waiting on the side.
Yeah.
So please come on in, Brent. Thanks for joining us.
Okay. Before we start or keep going, I'm just going to test your mic.
Yep.
We're going to turn that on. You can just say a couple words.
Hello. Thanks for having me.
Perfect. And you can hear us?
I can hear you.
Perfect. Okay, we're just going to make sure that mic's nice and close.
Yep.
There we go.
Maybe just introduce who you are and then who you're with, and then we'll use that as a mic test.
Sure.
Go ahead.
My name's Brent Hilscher. I'm with Sacra Davy Engineering. We do mining-related studies and construction projects.
Okay.
Perfect. Okay.
Okay. So thanks for joining us. This is actually your second engagement today, right?
Yep.
Well, I was trying to explain the event you were speaking at earlier, but I think I'll let you do a better job of it.
Sure. It was a session for sensor-based ore sorting, technology we'll talk a bit about today here.
Yeah.
Very popular this year. So it was standing room only in the back. It was just packed.
Yeah, there's a lot of interest in it,
Yeah.
and I've walked around the show a bit and talked, and there's lots of murmurs about it.
Yeah.
And we'll start off with your background. Kind of where you're from, and what you specialize in the industry.
Sure. So I've got going on 20 years of experience in mining. Went through operations in gold and copper, lead, zinc. The last 5-6 years or so, I've been in engineering, and recently gotten into, well, I guess 3 years ago, into ore sorting. Studies, construction, that sort of thing.
Yeah. So when we talk about sensor-based, I butcher it every time. You've been trying to teach me, but when we talk about sensor-based ore processing, what is? I mean, just in the simplistic terms, what is it? What are we talking about?
So you're using a sensor and measuring a quality of the rock. So it could be frequency of light, color, could be X-ray transmission or X-ray fluorescence, electromagnetic, infrared, laser. And you're looking at that characteristic of the rock and comparing it to a database of other rocks and for that deposit. And you're looking and saying, is this ore or is this waste? And can I train the computer to tell the difference instantly in order to divert that rock into ore or into waste? And it not just particle sorting like we explained here, but it could also be bulk sorting, where you can diverting hundreds of rocks at a time. Shovel sorting, where each scoop is analyzed. There's a lot of different potential uses for it.
So, so to go into that a little bit more, so at these different points, why would you? Some of the questions are going to be very simplistic questions from me, but why would at these different points, why would you put it there as opposed to another area? Is it depending on the mining operation, the type of mining?
Yeah, it'll depend on cost, tonnage, cost to process. So if you've got a very, very large open pit deposit, you're going to want to consider scoop sensors. You're going to want to consider bulk diversion systems. You may also consider particle sorting, but you don't want to jump straight to particle sorting because it's rather expensive per ton compared to some of the very bulk cheap methods.
Right. So could you explain particle sorting a
Sure.
little bit more?
So particle sorting is when the ore starts on a traditional conveyor, but is then spread out over a much wider conveyor so that each particle is exposed to the detector above it. All rocks are scanned simultaneously, and then as they fall off the end, the computer has by that time decided that, yeah, this is worth keeping, so it'll fall into the ore bin. Or if it's worth rejecting, could be a mechanical diverter or an air jet will bump it into the waste bin.
How accurate is this?
Your accuracy depends on particle size and your algorithm and your sensor, but 85 to 95% accuracy is pretty common. Could be higher, but it depends on the deposit.
I was doing a little bit of my own research on it, and it said some of the reasons that this is coming in now is because it's harder to find high grades
Oh yeah,
in
absolutely.
material now. So is it as a demand is why this is becoming part of the industry now?
Yeah, especially in the gold industry. Excuse me.
Oh, no worries.
The cutoff grade and the deposits available have been steadily decreasing in grade, and profits have suffered. To an extent, that's made up for by the rising metal prices. But if you can take a 2 gram per ton gold operation and bump that up to 4 or 5 grams per ton, your profitability just, the whole equation changes.
Yeah. And is it how much cost? So your higher productivity, assuming that you've actually got the material there to recover, but how much is the cost? Cost increase, I should say, percentage-wise.
So percentage-wise, we've never actually done it that way, but approximately 1 to 3% probably.
Okay.
Compared to traditional processing. It could be 5% up to, yeah. But it's very cheap and simple. You've got a sensor, you've got some electrical costs, you've got the conveyor. But compared to a grinding circuit or a flotation circuit, the costs are fairly trivial.
And where's the future going in this? Like, is this something that's here and now, or like, I mean, where is this going to end up?
So
5 years from now?
Right now, the top size limit is about 4 inches for a machine. We'd like to see that increased as far as possible. The higher the limit, the less crushing is required before sorting. Every time you crush, there's a certain amount of material that ends up minus ½ inch, which is our practical undersize limit. You want to reduce the amount that's undersized so that you can sort a higher proportion of your ore. Other improvements, sensor accuracy, sensor selectivity, and just overall equipment capacity.
Yeah.
For particle sorting, 100 to 200 is a fairly big machine. We'd really like to see 300 to 500 ton per hour machines.
Right.
But they're just not here yet because of the scale that would be needed.
There's something I was wondering too. Like when you take, let's say, a 24-inch conveyor, and that sensor is on that conveyor. Now, does it need different equipment, or does the software and the sensors work within basically any type of equipment where it's applicable, or does equipment need to be customized, or is the program customized to the equipment?
Everything is pretty much customized. So if you're starting with a standard 24-inch conveyor and you put a sensor above it, you won't be able to do particle sorting, but you could do bulk sorting. So the sensor would tell the computer, hey, look, the last 30 seconds we've had really good ore. Send this straight to the mill. And then a minute later, it'll say, okay, the ore that's been coming by lately has been very poor quality. Let's start diverting this to the waste piles.
So, who are the main players?
Well, you've got Steinert, Tomra, Redwave, Comex, Rados, and there's a few others too. And that's your particle sorting. And then you've got MindSense doing the shovel sorting. And you've got a number of other bulk sorting companies available. I'm trying to think of the name of it. I saw the guy at the conference here.
You can always tell us it later. We'll plug it.
We'll edit it in. That'll be fine. Great technology.
It's amazing what you can do. And these are these.
Oh, Scantech.
Scantech.
There we go.
There we go.
Scantech. Can't
Actually, we'll
forget
try
that.
to put those links into the descriptions as well. So
That would be fantastic. Yeah.
And so they're developing the technology and manufacturing, distributing it.
Exactly. Yes.
Yeah.
So we're an engineering company. We'll look at a particular deposit for a client, and then we'll look at all the technologies available and say, well, these ones have the best chance of working for this deposit.
Right.
Let's check these ones first.
And so, yeah, and that was actually my next question. So where does Saco Davy come into this process? And you're actually making the recommendations for this technology depending on their needs. So does that mean that you are specializing in this as opposed to another engineering firm that's not quite up to date on it, or how does that?
Well, we're definitely leaders in ore sorting, but we also do flotation and grinding and leaching and all those other things because we have specialists in all those areas.
Right.
But the last few years we've got the most traction with ore sorting. We've had over 30 projects in ore sorting, including some that were constructed and built, and we're building a couple more this summer. So it's definitely been the most popular thing we've seen in the last 3 years.
Right. Because of limited ability to, or depleted
just the
minerals.
economic impact
Yeah.
that ore sorting does. It's, when I tweak a mill circuit, I can squeeze an extra 3%, 5% from it. And that would be a huge accomplishment. Or I can trim a few million out of the budget. When you put in ore sorting, your production might go up 50% or 60%.
Really?
Yeah. So it's just a complete game changer, and that gets mining companies' attention.
Right.
A lot of times they'll be very resistant to any sort of change or any sort of new technology because that's the nature of the industry, and that's fine. But when you get a business case like this and it's so compelling, it's much harder for them to resist that opportunity.
Yeah. And are there mines? I know you said there's sort of the size or a limit on how big the sensors are.
Or each individual particle sorting machine, it's
Right.
limited to maybe a couple 100 tons per hour.
Right. So are there mines now though that are in that size range that have the full system in place? Are you seeing it now?
Yes, and I've seen packs of 5 to 10 machines. So they come grouped together. so they're able to do 1,000 tons per hour or something like that.
I mean, obviously, to me, it would seem that you've got this technology, and then you've got the OEMs that are manufacturing this equipment and bringing it to market. There must be a huge demand for partnerships in this kind of, to get this technology to a sort of a mainstream in the mining industry.
Yep, exactly. So I know MindSense is working with a few people in partnership. Tomra and Autotech have joined forces. Tomra provides the equipment and the experience. Autotech provides the sales power, and they've worked together. I think we're going to see a lot more of that, especially as this becomes more and more mainstream.
Yeah.
And based on reactions at this conference, I think it already is now considered a mainstream technology.
Yeah. But it hasn't gone through full implementation yet. It hasn't fully integrated into the systems.
Ooh, it has at quite a few places.
Right.
Maybe 100.
Yeah.
It's tough to get accurate numbers, as
Right.
a lot of places will not release their data. We were very happy to have 4 mines release their operations data to us so we could present it at this conference. But that's sort of a new trend.
Yeah.
So it's tough to tell how proven the technology is, but it's definitely very commercialized.
Right. Yeah. And actually, I'll wrap up with this question: is where, and I think you've answered it in some ways, but ultimately, where is it going to go? Is it going to become standard? You set up a mine, you have the sensor-based ore processing in place, like just standard.
It'll probably end up being one of the go-to technologies. So not every mine has all the same pieces of equipment, but things like SAG mills and crushing and grinding and flotation and leaching are pretty much standardized. So if you have a sulfide deposit, you do this and this and this. Ore sorting would be one of those pieces. And I think it will become more and more of just a step, a standard step that people take when they're evaluating their deposits.
Yeah, yeah. That's I'm going to add one more question for my own curiosity. When you talked about sorting, and before it goes into maybe it gets sorted before it goes into a crushing system, or would it not get sorted?
It could.
Yeah.
So some of the technologies before crushing. Usually if it's particle sorting, it'll be right after the first crusher. So your gyratory or your jaw, then your sorter.
So is that going to lead then to less wear so a more efficient operation, less wear, less maintenance on the machines, because you're not handling basically material that's doesn't need to be processed?
In theory, yes. In practice, it won't, because if I'm able to take 1,000 tons, reject 500 of those because they're worthless and we would have lost money processing. So those are gone. Now you've got a mill designed to be able to handle that 1,000, but you've only got 500 left. Yeah, you'd save on wear and tear and costs, and that's all great. But the first thing that mine is going to do is find another 500 tons to replace that.
Right.
So that's where you're able to, in that case, if you're able to replace that with an equal grade, you could almost double your mill production, metal production.
Now, is that in theory or in practice? Have you seen that?
We have seen
result?
That. Yeah. We've seen 90%, 85% recovery in 10%, 15% of the rock, and that mine is able to, if they can get it from their pit, they can produce double their metal.
Yeah, that's incredible.
And that was a tungsten mine.
Yeah.
Oh.
Yeah, it's a lot of information. I mean, in speaking with you, I first learned about the technology, so it's so new to me. So it's kind of when I'm, some of the other topics we cover, you can have some basic idea, but this technology is something that you really do need an expert. So. And
it's a very big topic.
Yeah.
At the CMP in Ottawa, we did a whole day session, just explaining all the different steps and all the different tests and all the different flow sheets and applications.
Yeah.
And it's an 8-hour topic.
Is there some sort of literature or a place that you would send someone who's just trying to learn it, or is it a little spread out at the moment?
It is a little spread out. There's a lot of papers, but there's not a beginner's textbook.
Yeah.
An idiot's guide to ore sorting.
Damn it.
There's some advanced textbooks, but it's tough to jump straight into that.
Yeah, yeah. Well, if you think of any,
I will let you know.
please let us know. We'll put those
Absolutely.
in the descriptions because there is going to be a lot of people that are interested. That they'll be similar to me and that never really heard of it before, or have heard of it but don't have a good understanding. And I guess if nothing else, they can get in touch with you.
Oh, of course.
Yes.
I'm always around. They can just give me a call.
Yeah. Okay, Brent. Thank you very much for joining us for the podcast.
Well, thank you for
Appreciate it.
having me.
Yeah. And I will catch up with you later.
Sounds good.
Okay. Thank you. Yeah,
Jared's just saying goodbye to Brent. And as he does that, I'll just say that was a lot of information. That's something that I had never actually heard of any of this. Just trying
thanks.
to
I appreciate you
understand
coming by for it.
what this sensor
Talk to you soon.
is kind of. It's literally out of my knowledge. Absolutely, I had no idea what it was. So now I'm basically just like Jared. I need a book, a complete encyclopedia
And
on
time.
this. Yes, because no idea. Sorry, my phone is doing something very weird.
Wow.
Apparently, it
What-
thinks
what-
I'm talking to it.
What is that?
That's Bixby for Samsung.
Oh, cool.
So
Bigsby?
Bixby,
Big or big? Big.
big, like BIX. Big-
Bixby.
Bixby,
Oh,
yeah.
yeah. So are we still rolling?
We are still rolling.
Oh,
yeah.
great. Yeah. I see. Sometimes you do these interviews, and you feel like you all of a sudden gained a bunch of knowledge. Sometimes you do, you're like, I think I just, I don't even know where to start now. So it's probably one of those
Yeah.
things. We'll probably have to get him in again.
I need him to for a couple hours just to really understand how the system works, how these sensors really work. I mean, I understand the whole it's a separation thing and that kind of thing, but it's like how is this technology?
Yeah.
I'm like a kid, the kid that constantly asks why,
Well,
why.
Well, here, I'll read a thing to you. So, various sorting solutions include, but are not limited to, X-ray transmissions, infrared technologies. Okay, well, you already lost me at those two because I don't even know how those things work. But, excuse me,
That's just like a whole nother, you need to be able to
you need to look at each
look
one.
up at all of these, yeah.
Yeah, I think what I would almost want to do is get Brent in again for another interview, and get him to talk about it in sections.
Yeah.
So do like a full hour podcast and go, okay, let's talk about this. So, because he's talking about in the loading process on an LHD
Yeah.
and into the trucks.
Yeah.
Okay, let's talk about that. What systems do they use there? Because that was a general thing of, okay, this is what it is.
Mhm.
It's sensor telling you if there's a high grade of
Yeah.
rare earth minerals in there. Okay, that's fine.
But
how
how does it actually do that? How does it
Yeah.
decide? You know what I mean? It's technology. You kind of a lot of the times it's hard to explain that there's a system in there that says this is.
Well, yeah, and you got to understand the engineering of it as well, right? I mean, it's not like they've been explaining or processing in general can be a challenging topic. Now you're adding on another layer.
Yeah.
I got to go back and read this list because I X-ray. So these various sorting solutions include, but are not limited to, X-ray transmissions, infrared technologies, color recognition. That's interesting. Okay, so it's like eyes. Electronic magnetic sensors. I'd be interested. So I guess magnetic products or materials maybe that senses that. Okay, X-ray luminescence. Photometry. I feel like I should know how to say that word. Photometry, radiometry, X-ray, fluorescence, visual spectrometry. I need to know.
Spectrometry?
Spectrometry?
Yes. So, where are you reading?
Trometry.
Yes. Electromagnetic. Okay.
Radiometry?
Radiometry. Photometry.
Photometry?
I really hope we're saying this correctly.
We're gonna get some Snickers for this next one.
Apparently, we can't speak. That's like a lot of, yeah, like just with that, I'm lost.
Yeah, that's
I'm
just the technology that's used. Now, where is that technology
and
used?
how is
How is
that,
it used? How is
yeah,
it applicable?
what does every little piece of that
Well, I didn't want to take
do?
up too much of Brent's time, but he's talking about, oh, so it sorts it. I'm going, well, how does
How
it?
d-
How does the equipment go? How does because I'm thinking, okay, it's a conveyor, but it's not, because I understand how a screen works. If you
Yeah.
put it through it, you've crushed it, it goes through a screen. So there's different sizes of material, and so that screen. But in this process, it's not about the size. It's not size based. It's what is actually in the material that it's basing it on. So then, how does it make that? How does that
Yeah.
equipment then split and to go to one
Yeah.
area over here and one over here? And if it's on a conveyor, I mean, it can't move it on the conveyor. So, I mean, obviously there's an answer.
There
I
is,
realize
but-
that I'm asking a question that maybe half the people watching me will already know, but
Yeah.
I don't know the answer. So, yeah, the other thing that I was reading about is what it can sort. I say I'm reading. I mean, Arjun does this research for us and does the digging, and I'd be lost without it because, again, understanding the basics of mining, I understand it, but when you get into the specialized stuff, it's so
Yeah.
you have to dig quite deep, and I didn't know. Well, like I look at something like this electromagnetic sensors. Okay, so that doesn't apply to, like, for example, you've got, this is all the applications, the mining applications that can be used. So industrial minerals, this would be your limestone, your quartz, calcite, phosphites, magnesite, and then it goes into stuff like slag. So it can be used for everything, like stainless steel, carbon steel, non-ferrous slag. I don't even know what half this stuff is. My goodness. And how do you say that word?
Ferrochrome?
Ferrochrome. You added in C's.
Oh,
and M's.
sorry. I don't know which one you're
Oh, no,
pointing at.
ferrochrome. Yeah, ferrochrome slag. Yeah.
And then
Ferrous?
ferrous metals?
Ferrous metals. Yeah. So those are your iron ore, your chromite, your manganese, coal and other fuels,
Oh.
and gems. So diamonds, emeralds, rubies, etc. So it works on all the technology. And I guess and now see, it starts to make a little bit of sense because when you're talking about all these different, the X-ray transmissions, the infrared technologies, color,
Yeah.
you need all these technologies to be able to accurately sense. And the other question that I'd be curious to know is
Yeah.
is all these technologies mixed in with one sensor? Is one sensor made with just one or two?
Yeah.
At different stages, are there different types of sensors? So yeah, it could create a lot of questions for me.
Yeah.
And I was just glancing over there because we got another guest coming in at 4, and they do, unless you want to see, I'm going to reach back here and get it. They're doing, I'm not sure if that's the gentleman that we're interviewing, but this is a company that's they're doing the sensors, but with a iPad. Yeah.
Oh, cool.
Yeah. So you can actually take a picture and do it. So then, I mean, I don't know. There's all this other technology. Are they using that as well? It's kind of amazing. I'm gonna just call Roy over for a second and ask him if someone is coming in. So I'm gonna move the mic away so I'm not yelling into the audience here. Roy, do you have our guest coming in? He's not here yet. Our guest is not here yet.
Oh.
But he's coming.
But he's coming.
He's coming.
Okay.
So I'm going to continue on going through this because advantages of sensor-based ore process according to Tomra and Sorting Solutions Technology Developer. So it's a lot of things what he was talking about. Yeah, decrease your mining costs, increase your deposit exploration and life of mine, reliable and efficient sorting, decrease your haulage costs, and haulage costs, that's because you're not hauling material that you don't need to haul.
Yeah.
Reclaim old waste dumps. This is something that is huge for the industry because they've processed these mine sites and processed all the ore, but this technology was, if it's from 50 years ago, some of the grade is as good as the grade that they're starting new mines as, or very close to. So they're going through and they're reprocessing this. That'd be another thing. See, I wish I had I should have kept them here longer and dug in. So we'll have to do another podcast because it was just so much good. Reduce energy consumption, reduce water consumption, increase production, reduce the amount of fine tailings, sell a coarse product. Yeah, so it's crazy.
Yeah, it's one of those topics that we just have no idea what it is, to be honest. I mean, or especially not how it works.
Yeah.
So it's really hard to kind of talk about it without
Without an expert, but
Yeah.
I think it does go back. It goes back to the idea that that mining is. People do not realize how much the technology. It's you get like placer mining even. We had Jordan on earlier with the high Gs and the trommels and the different types of trommels, the different sizes and different sizes of materials. It's that's just plaster. They don't even use chemicals. And then you get into the ore processing, hard rock mining, which is exactly what it sounds like. They're hard rocks. And when you crush them down and you have to find this gold within that, the technology and the innovation that comes out of mining, and I mean, they say mining is a slow moving when it comes to technology. And for me, it's kind of like slow moving compared to what? I mean, the energy industry, obviously, that's a huge push, especially for green initiatives and things like that. There's a huge push. But there's also emission things that mines are trying to get under. So there's that side of the technology. We were talking to a German company yesterday, and they have, like in the buses, the bus has the electric ones. They're electric powered buses in downtown, and they run on those tracks, right? Well, they're doing that in the mine sites.
Really?
Yeah, so it's a dual. So it's really interesting. He was a little bit shy to go on camera, unfortunately, but it was a really cool technology where what they were doing is, because the mine, they have to go into these different spots, right?
Yeah.
Especially like an open pit mine, as they're digging, so they can't set up the tracks every time. So the rock truck goes down into the site, into a very specific location, gets loaded, maybe with a sensor on it, and then it drives out to sort of the common track that's going to take it back to the plant. And then it hooks up to that.
Oh.
And so they're saving, I mean, thousands and thousands and thousands and thousands of dollars on fuel because it goes down into where it needs. And electricity is an incredible thing because a diesel engine has to churn and get the power up, right? But when you're talking about electric, it's instant. That's why it's a car like a Tesla. So imagine you get on this huge rock truck that's carrying thousands and thousands of tons, comes in, and it hooks on, and it's matched up with the right amount of electricity to power it, and it's just going along smoothly without that engine sort of resistant of the combustion engine. Wow. So
It's been a long day.
it has been. My voice is getting a little bit. It looks like it's got quite a bit of punch to it, though.
I think it's all the not coffee you've had.
I've been looking. How many times did I leave looking for coffee?
You told me like about 3 or 4 times that you were leaving for coffee.
It wasn't mess for. Yeah, it's not going to be coffee now after this. So I don't need coffee anymore. We're kicking it up a couple levels.
Absolutely.
By that I mean beer. Just to clarify.
Nothing else.
Yeah, I realized
beer.
that sounds. No. But I think I hope that this show is really starting to let people realize some of the innovation and what mines are doing.
Yeah.
And
I mean, you're talking about, mining is quite slow in comparison to a lot of other industries in technology. But I've walked around and I look at the amount of tech that is being showcased here, and I go, wow, like for a whole mining industry, it's not that far away with new technology coming in. Yeah.
No, it's well, and like he said, a lot of the technology is here. But it's integrating. We had another show about autonomous vehicles and that
That's
remote
right.
vehicles. It's tough to integrate it in. That's the challenge.
Yeah.
It's not the technology itself. It's the integration of the technology. It's the community's response to the technology, and that's going to be where the big challenge is. So.
Yeah.
We'll continue to see it. We'll continue to follow it, and I think we're still waiting for a guest. I don't know if he's going to come. We might have got ditched.
Oh no! Ouch.
But if we did, what are you going to do?
It's okay. We can take a break and
Take a break and get him back in later, and yeah,
create another podcast, another episode.
yeah. Another one today. We're not rewriting another one today. But we've got 2 more to do.
Yeah.
We were doing 5 in total at CIM. And we
That's a
just
lot.
got such a good response.
And that's just the podcasts themselves. We're actually doing interviews aside from that, so we're keeping quite busy.
Yeah, where can people go to see the interviews on our website? What is it?
It's actually crownsmen.com/interviews.
Yeah.
There you will find all the different interviews we've done throughout the years and the time. We've done a couple, with way before this, and there's also a few more. We went to the Quesnel Gold Show, and so there'll be those that will be going up soon enough as well.
Yeah.
Just getting edited.
Just getting produced,
Getting all pretty. So you can go there and the podcast as well at crownsmen.com / the Crownsmen podcast.
Yeah. And there was, it's. I actually think we have our guest has arrived.
Our guest
It's
has arrived.
fantastic. Oh, hi,
Hello,
Rory.
Rory.
Are
One
you
second.
are you our
Don't
next guest?
Let's hold on before we continue. Let me because otherwise we can't hear Rory. Let's try that. How about that?
Can you hear me now?
I can hear you now.
Okay, perfect. So Tom's going to be coming in, and
Okay.
he is from Whipware. He's got quite an interesting product line.
Yeah, I was looking at it earlier. So where did you meet Tom?
I met him, first I met him a couple years ago at CIM when
Oh.
we were here managing Savon booth.
Oh, okay.
But then I think I've probably tried to sell him a few times in the last couple of years. So.
Yeah.
But anyway, now we can have an interview with him and get to know more about his business.
Cool.
Sounds good.
We're
Bring
done.
him in.
So Tom, do I have
Tom-
some information
Tom
on?
with- I don't have his card, but Tom,
Okay. Well, I'll.
he
try.
probably has a card. So
Yeah.
I can see his name tag. I
Perfect.
can take care of it. Come on
Okay.
in, Tom. I'll switch you out with Rory. Thank you,
There
Tom.
we go.
Those on. Here we go.
Have a seat. Thank you for joining us. You are possibly our last guest of the day.
Oh, you saved the worst till the last.
No, I say
That's
the
the
best.
best.
I say the best.
Best.
Because this is about, let me make a quick introduction first. I'm Jared Downing.
Tom,
Hi.
I'm Gaudi Molina.
Gary Molina.
pleased to meet you.
Thanks for joining us. How's the show going so far?
Pretty good. Pretty
Yeah.
good. There seems to be a lot of interest in technology these days
Yeah.
and innovation and stuff like that. So that seems to be the buzzwords of the industry.
Yeah.
So
I'm sorry, before we continue, can I get you to kind of pull in the mic a little bit more into you? There we go.
Okay.
Perfect. That's a lot better.
Okay. And from what the interviews we've been doing, obviously technology is, it's coming up in every single interview, even if it's not the topic. We were talking about new versus used, and basically technology overshadowed the whole thing. So I think it's partially because it's now becoming like the technology is here. It is being used by mines. So it's a reality that's going to happen. How long has Let's start from the top. Who is your company? What do they do?
it's called Whipware, and it was some technology that I developed probably about 25 years ago when I worked for the DuPont company, the DuPont explosives, and we needed a way at the time to actually quantify blast results. So we kind of searched throughout the world, and we were looking for some way to be able to characterize or put a number to blast efficiency. And I went to Waterloo University in Canada, and they had this process whereby they were trying to enhance imagery and get some engineering data from it. And the name of our company is Whipware. The WIP stands for Waterloo Image Process.
Ah,
So nothing kinky about this.
Well, that's disappointing.
I lose a lot of audience that way.
I'm sorry. I'm just gonna
Yeah.
dot that down.
So, so we created this way where we would take a picture of broken material and from that be able to get some engineering data. Because before it would just, you'd look at a blast and you'd say, what do you think? Oh, it looks okay. But you really can't optimize a process unless you can benchmark it. You know, you don't know if you're getting any better or worse unless you can put some numbers on things.
Right.
Whether you're trying to manage time or distance or anything else, you need figures, units.
Yeah.
And so this enabled us to do that. And over the years, not only do we measure broken rock blasting, but the whole mining process is nothing more than a comminution stage. You know, you blast it, you crush it, you grind it, you mill it. So all of those stages, the material keeps getting smaller and smaller. And how do you really optimize a process like that if you don't know how well you're doing through every stage?
So does this fall under sensor-based ore processing? Or is it a different technology under a different flag?
I suppose you could regard it as sensor-based. Again, traditionally, if you wanted to measure the size of materials, you would pass it through graded opening, screens or whatever.
Right.
And that's still the de facto standard for doing granulometry. But in many cases, it takes a long time. By the time you get a sample, and hopefully it's representative, and you pass it through all these screens, and you weigh the fractions that are captured on each screen, and by the time you get results, it could be, many hours later, which is too late to act upon that information. Our technology allows you to measure that material in real time. And if you're off spec, you can adjust it. So and it's not disruptive. You know, we have online systems that measure material on conveyor belts. We have systems that measure material in haulage trucks, dumping throughout the whole process. So it's really quite.
When you say non-disruptive, what do you mean by that? Is it doesn't interrupt the system?
That's right. Well, if you wanted to get a sieve sample, you'd have to stop the production in order to get the sample.
Right.
And in the industry, that means you have to stop a conveyor belt and maybe lock it out so that it doesn't inadvertently start while you're on there. And then by the time you go through all that process, and that is just, data's only good if you get it in a timely manner.
Right.
You know, there's all kinds of people that collect data. But, if it's a month later, what are you going to do with that?
Yeah.
It might give you some ideas and some trending, but it's way, way too late to improve anything.
Yeah. You said you developed, as in you personally developed this?
Myself, and I had a couple business partners from Waterloo. Yeah.
Wow.
Yeah.
And so how has the technology evolved?
It's really evolved rapidly because imaging technology has really improved. So has computer technology. So has the various sensors. At first, when we developed it, you would actually go out on a blast and take a picture with an ordinary camera and bring it into a software program that would allow you to measure it. And now it's, there's automated online systems. We actually control production machinery now. In fact, we're finding that everybody carries a device. I've got an iPhone. I can use my iPhone to actually measure material. That iPad that you've got in front of you, you could use that to measure our stuff.
Yeah. And then now does that integrate it into a team, or is it one device, or does that get sent back somewhere, or how does that all work?
It could be any of those things. You could actually take a picture. You could do it yourself, or there's online systems that would feed it into a historian or actually control some production machinery. We even have people that are flying drones over blasts and taking those images and bringing them in and getting them processed. So it really opens up a whole bunch of different avenues.
Well, that must be just incredibly groundbreaking to be able to fly over,
Literally groundbreaking.
Yeah, yeah, no pun intended. Because the work that it would take to go in and do samples at one time, that's so this technology. Now, does it fully replace it, or does it give you a guideline to go, okay, there is something worth digging in and testing here?
It helps you at the start to design the blast. Explosives is a really, I'll say, complicated industry in that there's so many variables.
Right.
You know, the geology, the rock type, there's many different types of explosives. There's different timing you can introduce. I mean, there's so many things that you can do to affect a blast. There is an optimum size for every blast, depending on your production equipment and what the final use of it is. So you really need something to be able to track figures. You know, you could just track the characteristic size of a blast, and then you could wait until all the figures came in, you know, for maintenance, throughput, energy consumption, all of those things, and you'll soon twig in that, hey, when the size range is here, our production costs are there. And as the size goes this way, the production cost seems to follow it down. So it tells you right away where you should be going.
Right.
You know, and it's not always you have to make it finer, but in many cases it is. Maybe it's just to eliminate some oversize.
Right.
And so again, you need the tool.
So it's educating on you for the next blast as well.
Yeah.
That you'll and how you'll set things up.
Yeah.
What's a challenge? I'm sure with these new technologies. I'll say this in a two-part question. What is the challenge with the technology, as in what needs to get improved so it is even better, and entering into markets? What challenges do you face?
The challenges we typically found was you're trying to introduce a novel new technology into a traditional business.
Right.
Okay, so there's people that are saying, hey, I've been in this industry for 30 years and I never had this, we can do without it.
Yeah.
So they're not really they traditionally haven't been receptive to change like this.
Right.
But certainly now we're seeing with remote sensing, with robotics, with automation, I think the mining industry is going like the automotive industry is going.
Right.
There was a lot of resistance maybe to automation initially, but today you would never think about building an automobile by hand. It doesn't make sense.
Right.
And I think mining industry is going to find the same way that, it's the old ways we did things are probably, won't fly in the future. It just, you can't be cost competitive to do that.
Yeah. And are you seeing that shift firsthand?
We are.
Yeah.
We are. Yeah. We're global. We have clients throughout the world. Typically in maybe in Europe and more developed countries where labor rates tend to be higher and things like that.
Right.
They have to be more efficient if they want to be the low cost producer. And so they're really grabbing up on technology like that because it just makes so much sense for them. There's a big emphasis these days for things like environmental concerns. And so when you do it more efficiently, you're probably more environmentally conscious. Energy is a big thing for most people these days, and it's one of your big costs.
Yeah.
So it certainly reduces that. One of the most efficient ways of breaking material is still chemical energy explosives.
Right.
And so if you utilize them, if you don't blast it properly, then it's going to cost you more to crush it, and grind it, and mill it, and all the rest of it. So it's a big chain of events. You can't really look at one discrete element. You have to look at the whole picture.
Yeah.
And
I looked at, we did an episode about autonomous vehicles, remote vehicles, that we just did this on this sensor-based ore processing. Oh, excuse me. this doesn't seem. Now, are you putting now? I'm trying to get a clear picture. Are you putting the sensors on the machine, or is this all on picture based now? That this you choose where you're going to take a picture of.
We have systems that do everything. We have machines that actually measure material in real time on conveyor belts.
Have some water. Sorry.
We actually we actually have sort of robot machines that measure the material in haulage trucks as they're dumping. We take pictures of each layer as it ravels out of a truck,
Yeah.
and we analyze each layer, and then we put all those layers together. I can tell you exactly what's in the truck now. And then if I want to know what the blast is, I just take all the trucks and merge them together. Now I know what the blast was. And then we have other systems like that that measure the material that goes into a rail car or a ship, or anything like that. And one of the challenges we actually came upon, and I see you have this pamphlet in front of you, we thought creating the data was our reason for being, but it's not necessarily. It's getting the data to the people that can act on it. So we found out that, hey, we had a lot of clients that they have all kinds of data historians and that stuff like that. And if nobody looks at it or nobody acts on it, what good is that?
Right.
So we decided, look, everybody carries a device. You've got your iPhone, you've got your iPad. Let's integrate this so that when that data does come through, it goes right to your device. And now people are much more accountable. They can act on things.
Yeah.
Once you know what your optimum size is in an operation, you can design this operating envelope, and as soon as the curve goes out of that, it rings a little alarm.
Right.
So your phone can go off and you look and you can phone the plant. You can say, what's going on? Well, what do you mean what's going on? Well, for the last 20 minutes you've been running off spec. Oh, now somebody's going to act on this now.
That's interesting, yeah.
In the past, maybe your accountant to tell you at the end of the month, what the hell happened here?
Why'd
too
you lose?
late.
Why'd you lose $3 million?
So,
Yeah, it's way
you can understand how we've empowered people now.
Yeah.
And the people that are actually doing the work, they know they're accountable now. So we've created more of a factory mentality maybe to the mining industry.
Right.
So communications improve now.
And what
Okay.
now? This integration, how new is this with the iPad and integrating the technologies? Is that
We put this out 2 years ago. It was kind of an idea on my part. I thought, well, let's put this out. We'll sell it through the Apple Store. It's $1,000 a copy. Bang, away you go, because everybody has this already.
Yeah.
And there've been over 5,000 downloads, I think, in
Really?
the first 18 months.
Wow.
Yeah.
And actually, I had a question with the accuracy of this. Like, what is the accuracy?
It's very good. We can usually match traditional sieving. Sometimes we have to do a calibration, but no, it's very, very close. See, what happens, because this technology is so easy to implement, you tend to acquire a much larger sample. It's more
Right.
representative.
Okay.
Yeah.
If you had to go out with bushels or barrels or something to grab a sample, it's only going to be small relative to the whole thing. Whereas with imaging, because we don't actually have to grab the sample and that, we see all of it. Like statistically, it just overwhelms any errors that can,
Yeah. Okay.
And because it's imaging, it's scalable. So I can use the same device to measure material in the micron range as to measure something the size of an elephant.
Wow.
And there's not many tools that allow you to do that.
Right, especially in mining.
Yeah. And so it's kind of interesting and challenging. And
One thing you said that struck me is because on the Brent Hilscher was just in before you sat down, and he was talking about this sensor-based technology. And one of the questions I asked, well, does it save the equipment because there's less wear on the equipment?
Yeah.
And his answer was, in theory, yes, but if the plant is set up to do 1,000 tons, you're still going to want to run 1,000 tons through it. It's just now 500 of those tons
Yeah.
are not going to be wasted.
Yeah.
And that really struck me. It's not about running less through. And they bought the equipment because they want to use it, but they want the right stuff. And that's really where this technology is the game changer. Yeah.
Well, and in addition to doing, like, we actually measure size and shape, and we actually do volumetrics too, so we can tell you the number of cubic yards of material or cubic meters or whatever you went through. From that, you can actually maybe marry it with a belt weightometer and compute densities.
Yeah.
So a lot of these mining companies are processing. Certainly mining is nothing more than material handling, very sophisticated material handling. Many times they're processing material that's essentially waste. And so if you know the density, maybe sometime you can differentiate, oh, this is waste material, maybe we divert this off and not send it to the process. There's so many savings when you can start to do that, you know?
Yeah.
So.
Well, and what was the question I had? I had one of these questions I was going to ask, and I'm drawing a bit of a blank on it.
Yeah.
So I might have to come and find you again.
No,
to
no problem.
Ask you, but well, actually, something I was going to ask about it too is what is the technology? Because I was reading on one of my reports all the different types of technology that goes into these sensors. So this technology, what is it? Imaging? I'm assuming it's not using heat or some sort of magnet sensor. So what is the actual technology it's using?
It's just imaging. I mean, cameras have really improved. Computer technology's really improved. Lasers have improved. All of this stuff gets married together, you know, with this. It's. I don't know. It's just everything's kind of coalescing these days.
Yeah, it's absolutely. And will this be commonplace? I mean, you said you 5,000. Did you say 5,000?
5,000 downloads within 18
That's
months.
a
Yeah.
That's a
Unbelievable.
lot of downloads.
Yeah, I was expecting a
And-
few hundred of you to say, but
Yeah.
I was expecting 5,000.
Yeah, and it's a simple thing. I mean, anybody can use it. It's kind of a gateway product because we figure once people understand the value of data, they'll probably gravitate toward our automated systems.
Right.
You know, because your time is valuable too, and the drones. It really lends itself to drone technology.
Yeah.
They, you know, they blast the material. They send a drone out. It used to be you'd be out with a camera. It might take you 4 or 5 hours to take pictures on the ground.
Yeah.
And you can take the same thing in 4 or 5 minutes with a drone. It just flies the flight plan. The overlap is already there. The stitching is there. Bring it into our technology, and instantly you have the results. Like,
Yeah, even with you being involved in it and developing this technology, does it still amaze you when you step back and look at what is happening?
Yeah.
I find it, the more I look at it, the more unbelievable I find it.
actually, you know, and you won't be interested in this, but when we started this, and computer technology wasn't the way it is, we would take photographs, photographic film. This is 25 years ago. 8x10 photographs, and put tissue paper, and students in that would trace the outline of each and every particle. And then we would measure the areas of each of those particles.
Really?
And so when computers came in and digital images, I mean, that was a big breakthrough. So we've seen every step as they go through, you know.
Yeah.
And it's
And you're the president of the company, right?
yeah.
So for you, have you? This is switching gears a little bit on you, but you know, that's quite a jump.
Yeah.
To this.
Yeah.
So as leading the company, have you pushed for that innovation to keep on developing? You know, you hear a lot of noise about new technologies that are coming in and having to pick which direction to take. I mean, those are major decisions you have to make for the company.
Yeah.
So how have you managed those decisions? Is it your personality you kind of lean towards saying yes?
I've always been disruptive.
Right.
My teachers used to tell me that, and I used to think it was a flaw, but and maybe it is. But no, I like asking why, and I like disrupting things, and it's there's no status quo. You
Right.
keep moving,
Yeah.
and I've my son is very very astute when it comes to technology, and we have a real good team. And we work with researchers and all kinds of institutions and that because we're sort of at the leading edge. We get into other things. We've certainly done work for NASA and various aerospace organizations and that. We're talking here because it's a mining show. I'm talking to you about minerals and stuff like that, but this technology can also be used in agriculture. Okay, anywhere where you've got materials that maybe you want to detect contaminants, you want to, do some other things. Rice is graded based on the number of broken, medicine has some applications for us, like we can do cellular counts, we can do cultures and growths, and so it just goes on and on. The chemical industry uses us, the explosives industry uses us for measuring pearl sizes, because that's a very important parameter for making ANFO.
Right.
Emulsions, explosives are emulsions, and we count the micelles. So again, it goes on and on and on, but it's not just mining, it's a whole bunch of other things.
Well, and we focus on different. I mean, our role really is to support the industrial sector, and I hope you enjoyed the interview enough that maybe another interview somewhere down the road, and we can dig into a few other things about.
Always
what you do.
enjoy talking about myself.
That's a good thing.
And disrupting.
Yes, and disrupting.
Tom, thank you very much for sitting down with us.
Yep.
Appreciate it.
My pleasure.
Thank you so much.
No problem.
Yeah, you can just hang those up there, and Roy will make sure you get a pin on the way out. Thanks a lot, Tom. Oh, that's mine. Take care. Thank you.
Wow.
Well, I feel like we learned something.
I think we learned a lot of some things.
Yeah, I'm glad. When we do the full podcast, I think I don't usually edit down, but we might. We're about an hour, and can see it over on the clock.
Yeah.
We might. There was a gap of us, and we might cut it down so that people know. Or you know what? We'll cut it in to say something to let them know that he did show up, because I don't want people to leave that interview, because that is great information.
Yes.
And he knows the product, and I just, as soon as he said about the old way of doing it, I mean, it's one thing to come in. Our company's a little bit like that. We come in, and we got these brand new ideas, and I've said quite a few times to within the team we need to, as a company, integrate what they've got going on. And when he said that, they used to be drawing it out.
I know.
I mean, to me, that's leadership. That he has seen those opportunities with technology, and he's grown it into what it is.
Yeah, and it's not an easy decision to make.
No.
Especially because you never know whether it'll work or whether it'll be good. And the funny thing is, I think it is fantastic that there is an application for that. I mean, it's easy, like. Especially because we're trying to move away from paper.
Yeah.
And from us, or from me.
Yeah, we don't even use paper. Yeah.
We're a total paperless, and I say paperless, and there's paper here.
It shows up
company.
sometimes. Hide it under there.
We've managed to say 90% paperless. So it's kind of nice to see that there is a way, or we are. Not just us, but many companies are moving to become paperless.
Yeah.
And it's such easy. He said it himself. You have a phone. Why not use it for more than just what it is,
Yeah, and to that point and I think he's just nailing it with that technology, because it's not about. I think it's not necessarily about getting rid of paper. It's about making it better.
Mm-hmm.
And that is the key element is, in some things, if you want to write a quick note, paper is still so handy, right?
Of course.
So it has longevity in that way, and so it kind of hangs around.
Yeah.
But for this, it's so much easier to use the technology, and that's how I think people that are developing technology, and I think they do. I'm not, of course, not saying they don't, but that is the key to get people to accept it. When they look at it and go, "That is so much easier and will save me so much time and so much money," then of course they're going to be open to it. And I think Tom just
Yeah.
he exemplified that. I'm really glad he stopped by.
Yeah.
We didn't plug him very well. I just forgot to ask him about his website and that. So their website is www. You don't need the www. It's whipware.com. So WIPWARE. Whipware.com. And yeah, I mean, even if you're not into into mining. I mean, it's a neat technology to check out. And
Yeah.
like you said, we're going to get Tom back in. Maybe through. I'm seeing that they're based out of Ontario, so I don't know how often he comes out here. But maybe we'll keep in touch with him and hopefully get him. I'd like to look at some of the other, especially like agriculture,
Yeah.
and to learn about that
exactly.
technology as well. So. Okay,
I think that's
let's
a
wrap
wrap.
up. Yeah, let's tell people where they can find us. Gowdy.
You can find us at crownsmen.com and follow us on Facebook and Twitter at crownsmanp. We put a lot of these events on Facebook, so please check it out. We go to a lot of different trade shows and, whittle ourselves in there to get podcasts going at the trade shows. So please follow us. And you can follow Jared at Jared Downey and myself at Gowdy Molina too.
Yep.
And yeah.
And you can also join. This is brought to you in partnership with the IAC, the Industrial Alliance of Canada. That's a nonprofit organization. Their goal, and I am one of the board members, their goal is to promote the industrial sector and combat irresponsible government policies that make it hard for the industrial sector to grow and flourish in Canada. So it's got two streams, and that's why they support us doing the research and doing these interviews and doing the podcast. And you'll see in other episodes where we'll talk more about these policies that are just making it so tough to grow the industrial sectors, which just are high-paying jobs, huge opportunities, makes us a leader in the world for innovation and production. And so we really want to promote that. We appreciate the IAC. They've got a membership. It's $40 a year. It's just about showing your support and being a part of a group of like-minded people. So we want to thank them. And thank everybody for watching. We will be back at CIM tomorrow. For episodes 9 and 10.
That's right.
Yes. Okay.
Exciting.
Thank you, Gowdy.
And thank you.
Thank you for watching. We will see you tomorrow.
Bye.